Hello, welcome to my video. So, this video is my final exam. In this video, I will doing a presentation about set, relation, and function. Before I start my presentation, let me introduce myself. My name is Ninyomandia Idelia, with the last 3-digit number is 008 from 6B Mathematics Education. So let's recheck my presentation. Okay, first we discuss about set. Did you know what is a set? I have one country called Indonesia, and in Indonesia have 38 provinces. So the set is province in Indonesia. Set concept. Does anyone understand and can explain the concept of set? For the example, A is the set x such that x is a natural number. Set notation. First, the rooster or list method. Example, P equal to 1, 2, and 3. Second, the rule method. Example, Q equal to the set of prime number less than 10. 3. Set forming notation method. Example, P is the set x such that x is the day of the week. And 4. Venn diagram method. You can see the picture of Venn diagram on the screen. Next, we have empty set. An empty set is denoted by represented by the symbol on the screen. Example, the 40-year-old set of junior high school student. Next, we have finite and infinite set. The set is divided into two kinds based on the number of its members. There are finite and infinite sets. First, a finite set. A finite set is a set whose number of members of the set can be determined. Example, the set of natural numbers less than 8. So, A equal to 1, 2, 3, 4, 5, 6, and 7. So, and A equal to 7. Second, an infinity set. An infinity set is a set that cannot be definitively determined by the number of members because there are so many members of that set. For the example, the set of odd number B numbers B equal to 1, 3, 5, 7, and 9. Next, we have universal set. Example, determine the possible set of the universe from the following set. A is 2, 3, 5, and 7. Settlement 1. Suppose A equal to 2, 3, 5, and 7. Then, the possible universe set of the set A is S equal to prime number or S equal to natural number. Next, we have similarities of two sets. Two sets A and B are equal or identical, A equal B if only they have the same element. For the example, A equal to 2, 1 and 3 and B equal to 3, 1 and 2. Then it is said that A equal B. Two sets A and B are equivalent only if the number of members of the two sets is the same, even if the elements are not the same. For the example, A equal to set 1, 2, 3, 4 and 5 and B equal to set A, B, C, D, E. Then A equivalent B because and A equal to and B equal to 5. Next we have subset. Set A is said to be a subset of set B if every member of A is a member of B. For the example, you can see the diagram fan on the screen. We have A equal to set 1, 2, 3 and 4 and we have B equal to set 2 and 4. Then B subset A because every element in set B is an element in set A, but not vice versa. Next we have power set. A power set is a set whose all members are a collection of subsets. The power set can be 2 to the power of A or PA. For the example, if A equal to set 1 and 2, then 2 to the power of A equal to set empty set 1, set 2, and set 1 and 2. Next we have intersecting set. Intersecting set are if there are members of the set A and B that are the same intersecting set and can be as A cap B. For the example, we have A equal to set 1, 2, 3, 4 and 5 and we have B equal to set 1, 3, 5, 7 and 9. Then A cap B equal to sets 1, 3 and 5. Next we have independent set. A set is said to be independent if the two sets do not have the same members. Independent set can be as A and B are mutually exclusive. For the example, A equal to set 1, 3 and 5. B is equal to set 2, 4 and 6. You can see the diagram fan on the screen. Okay, now we discuss about relation and function. Did you know flight ticket relate to relation? This is flight path. You can see on the screen Bali to Medan, Bali to Jakarta, Bali to Sumatra, Papua to Sumatra, and Kalimantan to Sulawesi. So, what is the relation? A relation is the pairing of two quantities as ordered pairs. Symbol of relation is R. For the example, we have relation of going to. R to B is the destination of A. R equal to sets A, B, where B is destination of A, such A element A and B element B. Next, we have domain, codomain, and range. You can see on the screen, this is why flying ticket are related to relation. A to B, Bali to Medan, Bali to Jakarta, Papua to Sumatra, Kalimantan to Sulawesi. So, R is equal to sets Bali Medan, Bali Jakarta, Papua Sumatra, and Kalimantan Sulawesi. Next, we have example of relation. The question is, let P is equal to set 3, 4, 5, and 6, and Q is equal to sets 1, 2, 3, 4, 5, and 6. Let R equal to sets P and Q, where is P less than Q. P is element P and Q is element Q. Write R in the roster form. Draw R in the arrow chart and find its domain and ring. The answer, the roster form of R. R is equal to sets 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, and 5, 6. You can see arrow chart on the screen, and the domain is equal to set 3, 4, and 5. And we have range is equal to 4, 5, and 6. Next, we have the relation, which is function. The function is a relation where each input has only one output. The function is a relation from set A to set B. If every member of set A is pair one member of set B, all members of set A or the region of origin are expressed as domain, while all members of set B are called codomains. You can see the example, which one the function and not function. Next, we have inverse of function. An inverse function is defined as a function which can reverse into another function. In simple words, if any function f takes a to b, the inverse of f will take b to a. If the function is denoted by f or f capital, then the inverse function is denoted by f to the power of negative 1. You can see the illustration on the screen. Next, we have three properties of function. First, surjective function. The surjective function or onto is a function that has the characteristic that codomain members may have more than one pair, but there may not be unpaired codomain members. This is an example for surjective function and not surjective function. 2 is injective function. An injective function is a function whose codomain members is only paired once with a domain member. In the injective function, the members of the set of codomain may not have pairs, but for all members of the codomain that are pairing, there can only be one. There cannot be more than one injective function or interfunction or one-to-one function because each element is the codomain can only be related one. You can see the example on the screen. And the last, we have bijective function. The bijective function or one-to-one correspondence is both injective and surjective. In other words, each member of the codomain in the bijective function has one partner in the domain. In a bijective function between two finite sets, the number of domain members equals the number of codomain members. Let f be a function from x to y. The function f is called bijective if for every b element y there is a single a element x such that fa equal to b. You can see the example on the screen. Next, we have identity function. A function fx is called an identity function if every member domain function is valid fx equal to x or every member domain function is mapped to itself. The graph of the identity function is a straight line that passes through the origin and all points with the same axis and ordinate. The identity function is determined by fx equal to x. The function fx equal to x is used every time x. You can see the example for identity function on the screen. Next, we have constant function. A function will be said to be a constant function if in every member of the function domain set fx equal to c is always valid for the function f a to b for its fx formula. And c in the constant function is a number that is constant. You can see the picture on the screen. They are called domain and range. That is a constant function. For the example, the function f r to r by y equal to fx equal to c. Such x element r, where c is a constant and each x element r is called a constant function. The domain on this function is R and its ring is set C. The graph of a constant function y equal to fx equal to 2. You can see the graph on the screen. Okay, that's my presentation. Sorry if there are wrong words, so thank you so much. Goodbye.